With ordinary light, it can be difficult to inspect the surface of semi-transparent or transparent plastics. In this video, I will show you how you can use spectral imaging in the form of UV light to inspect tricky plastic surfaces. The use case here could be that you work in pharma and need to inspect a production line for medicine residues before the next batch can run. Or you're in manufacturing and need to ensure that there are no lubricants or glue residues on the surface of a plastic part. In this experiment, I've set up a normal monochrome camera and some blue light. The challenge is that these residues can be difficult to see on semi-transparent or transparent plastic surfaces. This is because standard visible light penetrates the material, scattering the light and sending it out in all directions, or in the case of a transparent material, penetrates it and reflects it on something behind the item. This refracted light drowns out, so to speak, the part of the light we need, which is the part that is reflected by the surface of our item. This makes surface defects or residues invisible. On one side here, the semi-transparent plastic block with a normal camera in normal blue light. On the other side here, you see the same object but in UV light. The solution is using spectral imaging in the sense of a specific waveband outside of the visual spectrum that does not penetrate the item, ultraviolet light. UV light has a shorter wavelength than visible light and reacts differently with atoms. This means that UV light is primarily reflected by the surface and that we avoid the disturbing refracted light and can get a detailed image of the surface. Traditionally, using UV light in industrial visual inspection has been a challenge, but the development of UV LED light sources is advancing rapidly, and you can now get much more powerful UV light sources at an accessible price than just a few years ago. This development is crucial to how viable the technology is, as the amount of light determines both how small defects you can find and how many items you can inspect per second. If you're working with UV light, it's important to be aware of possible safety precautions, as some UV light can be harmful to the eyes and requires the use of safety glasses. In addition, it will be necessary to use a filter that removes the visual light and, in some cases, use optics specifically designed for UV light with low wavelengths. In return, you get a vision solution that can make the invisible visible, so you can effectively inspect surfaces on challenging materials.